Hi, we are about to present our DE project through title, which is Application of Tsiolkovsky Rocket Equation in Calculating the Impulse of the Rocket. This is our content. Hello, I'm Choi Heng, and I'm now presenting the introduction. Firstly, a differential equation is an equation that relates a function with a derivative. It describes the rate of change of a variable depending on the value of the variable itself and the derivatives. Next, an ordinary differential equation, or so-called ODE, is a type of differential equation that involves function in a single variable and its derivative. A second-order ODE, however, is a specific type of ODE where the highest derivative that appears in the equation is second order. It can be written in the form of y double prime plus y prime plus y equals to fx. Lastly, the Tsiolkovsky rocket equation is a mathematical equation that describes the motion of a rocket in vacuum and is used to calculate the velocity, acceleration, and thrust of the rocket. The equation is used to determine optimal design parameter for a rocket and is important for the design of space flight system. So first of all, before looking to the problem, do you ever see before a rocket launch? The rocket name is Starship and it is invented by SpaceX, which the CEO is Elon Musk. It was a great success. Coming back to the topic, the problem statement is to find out what is the impulse experienced by the Starship rocket using Tsiolkovsky rocket equation. And the objective is to implement an understanding Tsiolkovsky rocket equation in calculating velocity, momentum, and impulse for a modern rocket. Next, this is our flow chart. First is finding the topic and determining its characteristic, whether it is ODE or PDE. Second is the confirmation of topic and start deriving the equation. Third is explore the problem involving the application of the solution. Fourth is solving the problem, and fifth is finalizing the result.
Now I'm going to present to you the method of derivation of Tsiolkovsky rocket equation. We start from step 5 to step 1. At step 5, we use a Newton's second law of motion relates external forces to the change in linear momentum of the whole system to get this equation. At step 4, we use a formula of momentum to get the equation of initial momentum P1 and final equation of final momentum P2. And based on these two equations, we proceed to step 3 to get the equation of change in linear momentum, which is P2 minus P1. And then after we get that equation, we sub it into the equation in step 5 to get the second equation in step 3. Now we assume that there is no external forces, hence we get the third equation in step 3. Based on the third equation in step 3, we integrate both sides with the term dt, and hence we prove that we get the equation of delta V equals to VE ln initial mass over final mass, which is the Tsiolkovsky rocket equation. The value given to solve our problem where we neglect the gravitational force and the drag force. Before we proceed to how we solve our problem, I will give a briefly explanation of what is Starship rocket. Starship rocket is proposed by SpaceX CEO Elon Musk for long-distance travel on Earth in a short time. It was claimed that it could carry somewhere between 80 to 200 people per trip. It is said that it could travel anywhere on Earth in under an hour. To find the impulse of rocket after launching, first we use the Tsiolkovsky rocket equation to find the velocity of exhaust in the rocket frame, which is the small VE. By subbing all the values given, we found out VE equals to 1.5936 meter per second. Then we continue to find the velocity of exhaust, which is the large VE, and since E is related to the small VE, hence we will get the velocity of exhaust. To calculate impulse, we need to calculate the momentum first. So first we will calculate the initial momentum, which is P1, and then we will calculate the final momentum, which is P2. By subbing all the values in, we get the value of P1 and P2, and then we know that impulse is a change of momentum, hence final momentum minus initial momentum, we will get our impulse is negative 3.903 times 10 power of 10 kilogram meter per second.
For the ways to overcome impulse of the rocket, first is the thrust reversal. Some rockets use thrust reversal to counter-track the downward momentum by redirecting the thrust of their engine in the opposite direction. Rockets can generate an upward force that helps it to slow down the descent. This is also commonly used in aircraft. Next is the retropropulsion. Retropropulsion also involving firing engine to counteract the downward momentum, just like the thrust reversal. By firing engine in a controlled manner, the rocket can decelerate and eventually to a stop. Lastly is the landing gear and braking system. Rocket may also have landing gear and braking system similar to those airplanes to physically slow down and absorb the impact of landing. This system can include landing legs, which provide a stable base upon touchdown, and brakes that can be deployed to increase friction and decelerate the rockets. In conclusion, it shows that rocket will have a large rebound motion after it reaches destination, which need to be overcome, and ways need to be taken to lower down the momentum and impulse for the safety of the passenger. Hope that in the future, the vision of town-to-town travel using rockets can be achieved. Let's hope it in the next 5 years. That's all. Thanks for watching.